Our objective for today, I can solve and graph absolute value one variable inequalities. Let's read together. 1, 2, 3. I can solve and graph absolute value one variable inequalities. Read it again. 1, 2, 3.
I can solve and graph absolute value one variable inequalities.
So we're still on the same concept, one variable inequalities, but today we're going to be focusing on absolute values. So please stay focused throughout because this is one of those challenging lessons. So please, pretty please, stay on task. Here we go. So on your Cornell notes, here we go. Your Cornell notes, let me show you how it should look. You should have your Cornell notes. Then you should have a column for the Q on this side. You should have your objective down here, your summary right here section, and that's crooked. And then at the top you have a section for notes, and your title goes up here, name, date, period on the right hand side, and all this is for notes, right? So now check this out. Here, instead of writing a Frayer model or writing steps, look up to the screen please. I want to divide this section of the notes in half, like this. Look up please. So you can either draw a line like that, or you can get this corner, fold it, or bring it together to this corner right here, and make a crease, and then when you open it, you see the division like that. Okay?
Mine has like no margins though. No margins.
Alright, here we go. So, right now when I give you the first examples, I want you to write those examples right here. Example 1 goes right here. We're going to do the work here, the graph, and then the check right underneath. Then we're going to write example 2, do the work here, the graph, and then the check right here again. When you go to the next example, you turn the paper over and you focus on the left side of your notes, right?
Yes.
Yeah, so in the back, you should also have a column on the left side, right? So, here we go. Copy this example down. Oh, by the way, we already know what one variable inequalities are. That's why we don't need a Frayer model. How about our steps? What are our steps? Simplify, isolate. That is correct. Simplify, isolate, plot, check. Example number 1. Copy this. Solve the inequality and graph the solution. Absolute value, x minus 1 less than or equal to 2. Copy that, please. Pens down, please, eyes up here. Now, let me elaborate first on absolute values. Pay attention, please. I'm going to revisit these really quick. In the past, I gave you stuff like this. I gave you stuff that looked like x plus 1 equals to 7. Then I gave you stuff that looked like 2 times the absolute value x plus 3 equals 10. Then I gave you stuff that looked like absolute value x minus 4 plus 3 equals 15. So I said, look up please. So for this one, since it didn't have anything outside the absolute value, at that point we wrote 2 equations. Remember that? One negative and one positive. So it was x plus 1 equals negative 7, x plus 1 equals 7. Are we there so far?
Yeah.
And then we solved and we graphed, right? Look at this one. This one, to get rid of this 2, I needed to divide by 2, and this became absolute value x plus 3 equals 5, and then from there I would write my 2 equations, one negative, one positive. Is that correct? You're just paying attention, please. So therefore it would be x plus 3 equals negative 5, and x plus 3 equals 5. So far so good? And then we solved and graphed. This one, to leave the absolute value by itself, I would need to subtract 3, subtract 3. This would be absolute value x minus 4 equals to 12, and again I would write my 2 equations, one negative, one positive. Are we there so far?
Yes.
Any questions with that? So with that said, let me go to the problem at hand. Oh, sorry. Look at this one. inequalities, we said that the processes are the same as equations. So the first thing I would do, I would draw my line down the inequality sign, and I would ask the question, is there anything in the front or behind the absolute value?
Yes. Yes.
No, there's nothing here or nothing
There's
here.
a positive sign, technically.
Okay, once again, is the absolute value isolated already? Yes, there's nothing in the front or in the back. Once we get to that point, we need to write two inequalities. I'm going to write a negative inequality and a positive inequality. Pens down, eyes up here, please, or you're going to miss it. So my first inequality, I'm going to write my negative one. This 2 becomes a negative 2. And if it becomes a negative 2, look what I do. If it stayed a positive, it stays the same. So think about it. Why do you think I had to do this? Think about it, don't say it out loud. Why did I have to do this for my negative and not the positive? Talk it over with your neighbor, please. Look up, please. So, if I, once again, go back to when we did inequalities. Look up, please. Just one variable inequalities. Pay attention, please. And it looks something like this. 8 greater than x over negative 2. To get rid of this 2, I need to multiply times negative 2 both sides. What happens to this? Switches. This is negative 16 and x. So it switched because I multiplied times negative 2, right? But what if I had this? Negative 2x less than or equal to 10. I need to divide by negative 2. And guess what? It switches again, right? And this is negative 5. So, it switches when we multiply or divide by a negative. So now let me go to what we just did right now. Stop writing, pay attention. I'll let you copy a little bit. Here it goes. What do I need to do to this 2 to become a negative 2?
Make it a negative.
How? I can't just do that.
By putting a negative symbol and by subtracting 4.
Very good. By multiplying or dividing by a negative. What is 2 times negative 1? And what is 2 divided by a negative 1? Negative 2. If we multiply or divide by a negative, guess what happens to the inequality symbol? It switches. We understand that?
Yes.
Okay, at that point I'm going to solve. Check this out. Plus 1 plus 1. This becomes x is greater than or equal to negative 1. This one plus 1 plus 1. X is less than or equal to 3. Copy that, please. At that point, I'm going to draw a number line underneath. Pens down, eyes up here. I'm going to zoom in so I can show you something here. Hopefully you will see it right away. Look up, please. Here we go. Pens down, eyes up here. So notice here, instead of having one inequality, now we have two inequalities. Yes? I'm going to graph first the one in red. Here we go. Pens down, eyes up here. So I'm going to start with my dividing point, which is negative 1. Does it include the point? Yes, because it's got an equal sign. So I'm going to put a point, and it's a solid point. There it is. I'm going to test another number, so I can substitute in here. I'm going to test 0. Is 0 greater than or equal to negative 1? Yes, if it did work, well, that means we're going to shade this inequality going that direction. Are we there so far?
Yes.
However, now we have another inequality, which is this one. That means my dividing point for this one is 3. Are we there so far?
Yes.
Okay. Here it goes. So I'm going to graph this. My dividing point is 3. It does include the point, so I'm going to plot a solid point, and I'm going to test 0. Is 0 less than or equal to 3?
Yes.
Yes. Is 0 less than 3? Yes. That means for this blue one, the solution should be to the left. But what do we notice here? that both solutions intersect, the red and the blue. Do you guys see that? That's why for this absolute value inequality, the solution is this section where they're intersecting. That's why these kind of inequalities are called AND when they intersect. Because the solution for the inequality that we started with is this one and this one together. Copy that, please. Okay, here we go. We're still not done.
How is it so easy?
Well, for some, but it's not for some others. Here we go. Now I'm going to write my solution set. Look up. Here it goes. Solution set of all x such that, pens down, eyes up here. Here we go. I'm going to first write my two extremes, -1 and 3. What variable does this represent? X. And we know it's a solid point here, so this one is less than or equal to, less than or equal to. Copy that, please. So far so good?
Yes.
So let me go through the process again to make sure we got this. We started off with when an inequality, absolute value inequality, and I said, is there anything in front or behind the absolute value? No, it's already isolated. So from there we wrote two inequalities, one negative, one positive. But then here I showed you that for the negative we flipped the inequality symbol here. Why? Because in order to make it a negative, we either multiply or divide by a -1. From there we solve each one, there it is, and then we graph each one individually. So if I graph this first one in red, it goes that way, this one went that way, and I saw that they both intersected. If they both intersect, this is what we call an AND inequality. Once we have that, we write our solution set, x such that -1 less than or equal to x less than or equal to 3. This is what we call a compound inequality. Compound inequality.
Oh my God, that's English.
So, with that said, let's check this. Hold the question. Let's check this to see if it's true. I'm going to write it on the right side, but you write it right underneath. Yes? Okay, here we go. Check. Absolute value x minus 1 less than or equal to 2. So, I'm going to check a point anywhere in between -1 and 3. Which point will you want to check, Elizabeth?
4. Oh my God, 2.
Absolute value 2 minus 1 less than or equal to 2. 2 minus 1 is 1. So what is the absolute value of 1? What is 1 less than or equal to 2? Yes, that is correct. We tested the number 2, which is right here, and it did work because it's in between these 2 points. Okay, let's move on. Copy this next one down, please. Example 2. If it doesn't fit, you do that in the back. Example 2. We got solve absolute value of x minus 3 less than 1. -1. All right, here we go. Let's do this one together. Line down the inequality symbol. Is the absolute value by itself?
No.
No. What's next to it? So that to cancel that, we add 3, add 3. Absolute value of x less than 2. From there, I write my two inequalities, one negative, one positive. If I write this as a -2, what happens to the inequality symbol? Switches, and I write x. This is a positive, it stays the same, and x. Now look at here. At this point, can we solve anything for each one of these? No, it's already solved. Who notices that? Yeah, right? So let's graph. Draw your graph for this one. Zero. I'm going to graph this one in red first. So I'm going to start at -2. It's an open point. And I'm going to test 0. Is 0 greater than -2? Yes. If 0 works, that means I'm going to shade to the right. Next, I'm going to graph the other one in blue. Start at 2, open point, and I'm going to test 0. Is 0 less than 2? Yes, if it worked, that means for the blue one it's going to go that way. And what do we notice? They intersect, right? So this is an and inequality. So far so good?
Yeah.
Let's write our solution set. Solution set of all x such that -2 is less than x less than 2. Let me do the check to make sure that we understand what we're looking at. Check. I'm going to write my absolute value of x -3 less than -1. So, my solution, what number should I choose to check for my solution?
One.
Julia.
0.
Julia.
Yeah.
1. Does everybody agree that 1 is part of the solution set?
Yes.
Yeah, so let's test 1. Is 1, absolute value of 1 is 1 -3 less than -2. 1 minus 3 is -2. Oh, this is 1, sorry. Less than -1. Is -2 less than -1?
No.
Yes, that is correct. So that does work. Are we there? Do this next one, please. Example 3. Do this one by yourself completely. See what you get. Here we go. Example 3. Let me zoom in. This is 2 times the absolute value of x less than or equal to 6. Solve for that, graph it, solution set, and check. Go. Okay, here we go. Line down the inequality symbol. To isolate the inequality, there's a 2 multiplying, so I need to divide by 2. This becomes absolute value of x less than or equal to 3. Are we there so far? At that point, we write 2 inequalities. One negative, one positive. This -3, if we wrote a negative, that means we flip the inequality symbol, and we write whatever is inside the absolute value. This one is a positive. The inequality symbol stays the same, and we write the x. So, at that point, we graph. Get my graph. Here we go. I'm going to graph this one in red. -3 is my dividing point. Does it include it? Yes. It's got an equal sign right there. So, I'm going to test 0. Is 0 greater than or equal to -3?
Yes.
Yes. So that means it's going that way. Now I'm going to graph this one. 3. Does it include it? Yes. I'm going to test 0. Is 0 less than or equal to 3? Yes. So that means it's going that way. Therefore, this is an and. So I write solution set of x such that -3 less than or equal to x less than or equal to 3. Hands if you got that. Okay, good. The check should look something like this. 2 absolute value of x less than or equal to 6. And I'm going to check any number in between here. Could it be a fraction? Yes. Could it be a negative? Yes. I'm going to use a negative number. I'm going to use negative 2. What is the absolute value of negative 2? 2 times 2.
4.
This is 4. Is 4 less than or equal to 6? Yes. Everybody got it?
Yeah.
All right, so go back to the top of your paper, and now we're going to start on the right-hand side. Here we go. Copy this next one down, please. This was example 3. This next one is example 4. Copy this one. Oh, hold on. This one. Example 4. Even though it says 5, copy and write example 4. Example 4.
We have to write the next section.
No, they're the same. Here it is.
Wait, I have a question. Okay.
Hold on.
Is there really a number called infinity? Like,
No, it's just a matter.
like how many
It's a symbol.
zeros are there?
It's infinite.
Do you have a lot?
Okay, here we go. Line down the inequality symbol. Look at the absolute value. Is there anything outside the absolute value? Yes, the 3. How do we get rid of that 3? Subtract 3. Subtract 3. We're left with absolute value, x plus 2, greater than 2. Do you know what to do from there?
Yeah.
Okay, finish it off, please. And then when you get to the graph, just make a number line, and then we'll do the graph together. Go. Okay, here he goes. Is there anything else outside the absolute value? No. At that point, we write two inequalities, one negative, one positive. This becomes a negative 2, and I flip the inequality symbol, and I write whatever's inside the absolute value. This one stays a 2. The inequality symbol stays the same. I write x plus 2, and I solve. Minus 2 minus 2. X is less than negative 4. Minus 2 minus 2. X is greater than 0. Hands if you got that. Okay, at that point I'm going to draw my number line. Zero's right here. I'm going to graph my first inequality, negative 4. It's right here. Does it include the negative 4? No, so it's an open point. And I'm going to test 0. See if this is a solution set. Is 0 less than negative 4?
Yes. No.
No. That means I cannot shade this way, so I need to shade that way.
Mr. Q, I still don't get why it's negative 4. Wait, what? Oh.
Next. 0. I'm going to graph this one in blue.
Mr. Q, don't you make this fine?
No.
Don't worry.
I already switched them. Here we go. This is 0. And I'm going to test a point. Since I already took over 0, I'm going to test the next one up, which is 1. Is 1 greater than 0?
Yes.
Yes, if it did work, that means it's going to go that way. And you're saying, wait a minute, this is a little bit different. Who noticed that they do not intersect? This is what we call an OR inequality. Why? Because a solution would be this one or this one. Everybody understand? Okay. Let me write the solution set. Here we go. Solution set x such that. Look the difference for this one. Pens down. Look up. Watch. For these OR, they don't go exactly like the other one. All I do is write the first inequality, x less than negative 4. I write the word OR, and then I write the second inequality, x greater than 0. Copy that, please. So, at that point, let's do a check. Let me zoom out. I write 3 plus absolute value x plus 2 greater than 5. I'm going to use, for this one, with that said, the solution, according to what we wrote, is this one or this one. What does that mean? That it could be either this side or that side. Let's see. I'm going to choose a number from this side. Which number should I substitute? 2? Okay, I'm going to substitute 2, which is about right here. So let's see. What is 2 plus 2? 4. What is absolute value of 4? 4. And this is 7. Is 7 greater than 5? Yes. What if I substituted a number from this side? Would it work? Of course it would work, because this is a solution for the other one. Let's see. What other number would I substitute for this side? I'm going to substitute negative 5.
Wait, for the right side on the problem, the positive, on the actual problem, on the solution for the right side, the positive,
Yeah?
I don't get why the sign flipped. Like, I don't get why
It didn't flip. It stayed the same.
How come the other one did there?
Because it becomes a negative.
Oh, okay, I get it now. Okay.
Okay, here we go. So I'm going to check now with a negative. Let's see. We got 3 plus absolute value x plus 2 greater than 5. I'll wait.
Stop.
Okay, here it goes. So I'm going to test 1 point from over here, negative 5. Okay, so this is 3 plus absolute value negative 5 plus 2 greater than 5. What is negative 5 plus 2? That's negative 3. What is the absolute value of negative 3? 3. What is 3 plus 3? 6. Is 6 greater than 5? Yes. That's why both of them work, because that's the solution. So therefore, the solution set was this or that. So now let me show you something that I wanted you to see. Here it goes. Let me go back to the previous ones. We started with this one. Look up, please. What kind is this? An AND. Observation. Look where the arrow is pointing. Okay? This is number 2. We ended up with an AND. Look where the arrow is pointing. This one, the inequality arrow, okay? Let me go to the next one, number 3. We ended up with an AND. Look where the arrow is pointing. Then we ended up with this one. This is an OR. Look where the arrow is pointing. Does everybody see that? So therefore, what can we conclude? That when we have an absolute value inequality pointing to the left, it's an and if it's pointing to the right, it's an or. Everybody with me?
Yes.
Okay. So, to summarize, once again, if you have absolute values with arrows pointing to the left, it's an and, this is an or. And I got 2 more to go. Have a seat. Here we go. Okay, look at these 2. If I was to solve this one, add 5, this becomes absolute value x plus 4, I'm sorry? Greater than negative 3. And this one, absolute value, minus 9, absolute value x minus 2, less than negative 2. What do you notice on these? That this number is a what? A negative. So these must be important. So check this out. Is there anything else outside the absolute value?
No.
Let me ask you a question. If I substitute any numbers into an absolute value, they always come out what? Positives, right? So if I substitute any numbers in here, the answer is always going to be what? Positive.
Oh, yeah. Okay.
Okay, let me go back again. If I substitute any number into the absolute value, all the numbers come out what? Positive. Therefore, any number that I substitute here, it's still, the answer will always be what?
Positive.
So what do we have on this side? Negative. So does it matter what numbers I substitute in here? Will I always get a positive?
Yes.
That's why whenever you see an absolute value greater than a negative, This one is all real numbers of solution. However, look at this one. This, we said, is a positive. Is a positive less than a negative?
No, yes. Sorry.
Is a positive less than a negative?
No.
No. Therefore, whenever you have an absolute value less than a negative number, this one is no solution. Those are the only two situations that you're going to encounter when you have negatives. So home play for tonight is on page 723. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Lunch.